Good day to Sir Ashley and my fellow friends. My name is Neellesh, son of Silent, student ID TB25046. For today's presentation, I'll be talking about my assignment BTE 2442 Maintenance Technology Assignment 1. Well, I'll be discussing RCA. RCA, what is RCA? RCA is root cause analysis. So, without further ado, let's discuss more about this topic. Let us discuss about RCA for root cause analysis cooling water pump motor. What tag number is 71PM05, where this motor I have repaired during my time at internship at IFF Penang. So let us begin with the problem description. Let's start with the problem description. The equipment in question is the cooling water pump motor located at SPD plant process area. So the failure event detected during the time was a routine inspection round. The operator reported an excessive vibration sound and a loud abnormal noises coming from the motor with a non-drive and bearing. This is critical issue because if the pump fails, it carries a high risk for the cooling system breakdown. Imagine that, which could lead an unplanned and costly plant shutdown. This caused a lot of problems for the production and unwanted necessary maintenance afterwards. So you can see here, this is the motor with the old motor, where this is the pump number 71PM045 cooling water pump at SPD plant at IFF Penang Union Berhad. So let us discuss what's actually problem and we can see how we can solve it. As I mentioned before, during the inspection routine rounds, during the ex, they take, doing the operators detect an excessive vibration and loud abnormal noise. This is because coming from the non-drive bearings. What is the operational impact? Is the high risk of cooling system breakdown, which could lead unplanned plant shutdown. So this is really bad. Let us discuss what are the RC theories and tools that I use for this assignment. So I use Ichikawa fish product, which is I will explain later on. What is actually Ichikawa fish and what's the purpose? It's to categorize the causes into man, machine, method, material to find the root cause and not just the system. So these categories from man, machine, method, materials, and environment, the tools being used, these are categories to identify what is the actual problem for this particular model. That's why I chose root cause analysis so that we can understand even better and even deeper about what is the problem of that motor. So we're using some root cause of the pump run out. This is the engine concept I will explain on. Is pump run out is the main issue right here. So let us discuss in further. From there, I understand what we can find. What's the problem we found out as during the centrifugal pump, power consumption is same as proportional as the flow rate. If the flow rate is of the motor going very high, like 100%, a lot of amps, lot of current is being used to the motor. This can cause a lot of problems such as grease degradation, overheating, thermal tension, and so on, and this could cause unwanted breakdowns for that motor and causing that is the cause of the vibration and motor because the parts in the motor are causing breakdown itself using because grease degradation and grease melting. This causes the motor to lose its performance. So and we're going to find out using the fishbone diagram to understand even better. To determine why the motor was overloaded, I used Ishikawa fishbone diagram. Based on the feedback, I have classified the cause into three specific categories, which is first, physical cause. This is the mechanical failure. The bearing failed due to grease degradation caused by severe thermal stress from high currents. So this is because of high current, higher power is being used to the motor. The motor create a lot of heat. Because of the heat, the grease of the motor degenerates, degradation happens. And because of that, the second cause is the human cause. This is why in error of consumption and the operator open discharge valve at 100%. Imagine during the startup failing to throttle the flow, because since the flow of the valve is at 100% is proportional to the power consumed by the motor. This is why because of the high amps and the flow of the motor at 100%. So the third is the latent cost. Latent cost, this is the systematic issue. There was a lack of training regarding the pump curve and physics, and no SOP was in place mark the correct valve position. As you can hear, the data collection and safety, where we'll be discussing what is the safety being taken care of. Safety compliance, we have to follow in IFF, we have to follow very important uh, safety measure where we have to plan LOTO, lockout, takeout, where the main brake is isolated before mechanical work. We wear PPE when we go inside of the plant, where is personal protective equipment, safety gloves, and uh, wearing gloves to safety gloves and using protective tool during inspections and verification. We have to verify that zero energy at terminal box before touching it. So there's no electrical energy, and because so that we don't be shocked by it, cause any electrical shock. So we must verify that it's absolutely no electrical flow going there. And let's see the site evidence and data. As you can see here, the max coming from the uh, motors plate, where it's 2.28. That's the limit. If you go beyond that, it's cause a lot of huge problem for the motor. And the maximum current we got is 27.428, where the quita is already critical and the discharge pressure is already 5.8. So this is very all the evidence data because if meters have not been done yet. So we pause the root cause identification. System bearing causes the noise amps erection. Investigate high amps. We found during the investigation of the root cause analysis, motor users draws a high amp power 2748 was too very high. It's very unsafe, very causing too much power to be drawn because the valve was open. Because the discharge was 100% and the motor was running 24/7 run without rest, it caused the motor the performance to decrease, the grease of the motor decrease, causing a lot of problems and vibration and loud noise coming from the motor. Root cause error method is the valve setting was incorrect. We found number one, the root cause incorrect settings because of the one of the operators caused a wrong setting. The valve setting was incorrect, causing the pump to run out. So we identified that root cause the discharge valve was 100% where flow of maximum water. The process where the pump run out max flow rate measurement, where we got the measurement of 2.7458, and that is the max, and we measured for 24.28 condition thermal stress overheating. Because of overheating system, the system decrease melting and bearing failure. Solution and preventive actions we took. These are the solution and preventive action we took. Conclusion and solution. Our corrective action is to replace the damaged wire. Because of the loud noise, of the high vibrations, a motor with a new be replaced with a new 50 kilowatt taco motor. Same model we use, the same brand we use, so that we replace the overall relay and repair the heat damage caused. Preventive action, that throttle discharge valve reduces the, we have to use the flow manually. So currently the drop to 25 amps safe zone. 25 amps now we have been set to the motor, and that will be drawn out, and during that the setting we set the flow rate to around 50% only. So because of this, this helps to monitor the amps and the valve flow easily. So that is all. Thank you so much for this presentation. I hope you guys learned something new, and thank you all. Thank you so much for listening to my video.